first part of our presentation, I will be going through what essentially will be a crash course into digitalization and the digital energy transition. So the basic aspects, the challenges, and the technologies that are required. So this is digitalization, but we'll focus more on what's going in the energy sector, so not spreading to the concept in itself, but more focused on the energy sector. So next slide, please. So there are two main concepts in our project. So one is digitalization and one is digitization. And they are essentially different because the first one, the digitization, is the process when we change something from the analog format to the digital format. So for example, if I have a piece of paper with some information, a document or something in a physical state, and then I convert it to a digital format, I'm digitizing. So I'm not digitalizing. This is not true in all languages probably, but in English is, and we have made it. So we want to make it really clear that there is a difference between these two concepts. So what is digitalization in a broader sense? It's when you take those digital technologies and use them then to change the business model so it's more profitable or more simplified, and that's essentially the main difference. But this is very broad, so then I want to give you some aspects on how this translates into the energy sector. So if we could go to the next slide, please. So if you are all aware, nowadays there's a transition going on, for example, in the smart meters. So usually you used to have in our households and commerce and businesses something like the energy meter on the left side. And now we are going to we're moving to the one on the right side. So we are moving from an analog meter to a digital meter. So essentially this is what we can consider digitization. And this is an enabler. So the smart meter will now be an enabler for digitalization. So usually on the past, we used to receive our energy bills at home via the mail. So it could be a letter or something similar. And nowadays with the digitalization of the process, thanks to an endless number of enablers, and a key one is the smart meter, of course, we can receive our energy bill on our smartphones or in our email. So we're moving from a physical service or more an old school service where you use paper and the mails and everything to a digital service where we receive our information in a digital format. So essentially the conversion of the service from a physical format to a digital format is what is called digitalization. Next slide, please. So when we look especially at the energy sector, what can we say about digitization? So this is the installation of several devices like smart meters that I've mentioned, the smart chargers for EVs, for electric vehicles, so home energy management systems that you can have in your household that control your energy consumption, smart appliances and sensors and other components. So the installation of these technological components is what we call digitization. And they can be seen as the digitalization enablers. They are the technology that will enable the digitalization of the energy sector. And this digitalization of the energy sector is what is achieved via the creation of the digital services. Digital services that are the services that use the enablers to create a new business model. So can we go through the next slide, please? Thank you very much. So how does this impact now I'm going to go a little bit through how does this impact the citizens, the public sector and the private sector, so more commerce. So regarding the citizens, if we go through with this digitalization of the energy sector, there will be a number of advantages for them. So one of them is in the increased access to real-time to their energy consumption. Instead of being just focused on the energy meter, that was the only place in the household that we could check our energy consumption. And even so, it would be very hard to understand if you don't have the literacy for that. Nowadays, you can check it in your phone, in your computer. So there's an increased access to real time. So it allows for a better understanding of what your consumption is and how you can manage it and how you can improve it. And this is also achieved through smart home technologies that allow you to remotely control, for example, your washing machine, your heating, your cooling. So through smart technologies, this is also an advantage for the private citizens. And this is very good because it has a potential to save costs. So if you, in the early days, also in the past, if it was a cold day and you leave your heating on and you went outside your home, then it would be turned on the whole day. Nowadays, you can probably, with the new digitalization and the digital technologies, there are already means that you can control what's happening in your home outside of it. And this helps you save costs. Also, you have an increase in reliability and the resilience of the energy supply. And there's also opportunities in the future, there will be opportunities for citizens to participate in demand response programs where they can shift their consumptions to periods that there is consumption required or to move the consumption from high periods to low periods. So the citizens will also have a key role to play in the demand response. So next slide, please. The same now for public stakeholders, and by this we mean government agencies and grid operators like DSOs and TSOs, and what can they expect as benefits from the digitalization of the energy sector. So they can expect the improved grid monitoring, so with the sensors and all the digital technology that can be installed in the distribution network and the transmission system, they can expect to have improved monitoring and a new, much more control capabilities. So although this is already true, for example, in the transmission network, for the distribution is not so true. So there's a lack of monitoring and control capabilities in the distribution network, and this is due to historical reasons, how the grid has evolved. So through digitalization, and I will explain this a little bit better in the upcoming slides, there's also a high enhanced integration of renewables. Mainly due to data analytics and forecasting, they can be better integrated into the energy mix, and this will in turn facilitate a transition to a more greener system. This is what we are expecting to see with the digitalization transformation. Regulatory compliance, so with automated reporting, will also be much more easily achieved. There will be better coordination because we have improved grid monitoring. There can also be better coordination and response to grid disturbances, because if I have more information on how the grid is behaving, and if I have more control capabilities, then I can better coordinate in case of an emergency, in case of an outage or an accident, if something goes wrong in the power transformer or something, there's much more information, and I can then use it to much faster solve that issue. And also we're also expecting to see some facilitations on the energy market liberalization. This ties also to what I previously said about the private citizen being able to participate in demand response markets. And this is also true for the public stakeholders. So next slide, please. Finally, for the private stakeholders such as big industries, factories, and commerce, we can see with the digitalization, so with the digital technologies, services, and products, we can see an optimization of industrial processes. This can be achieved once again by data-driven insights. So we have much more monitoring of the consumption, so we have much more information, and with that information comes knowledge, and with knowledge comes the power to make things better. So we will have greater flexibility in energy procurement, enhanced energy management, as we also had for the citizens and all the sectors within the energy sector. and there will also be some facilitation of corporate sustainability. So again, if we know what's happening, we can better tackle it. Finally, some opportunities for revenue generation, because factories will now be able, and heavy consumers or high demand consumers will also be able to participate in demand response markets, in flexibility markets, and in virtual power plants to not only consume but also supply energy to the grid in a much more streamlined manner or fashion. So next slide, please. So this is all very interesting and very, it seems to be very simple, but it's actually based on some key components. And what are those key components that are emerging? Some of them have existed for quite some time, but others are much more newer to the scene. So first of all, the Internet of Things, or IoT. So by connecting thousands and millions of sensors and energy assets all together with sensors and smart meters, we create a grid of information supply that will greatly benefit the transition to the digitalization. And this increment of information, this exponential increase of information, will only be useful through data analytics. So with data analytics, then we'll be able to leverage to make informed decisions and improve efficiency, and also predict demand and production and generation and so on. So for forecasting. And this data analytics, with such big data sets and such thousands and millions of information points, this can only be processed through machine learning algorithms and artificial intelligence that will not only allow us to forecast the energy consumption and the energy demand, but they will also help us to predict maintenance requirements from anything that is connected to the grid. For example, power transformers, heavy consumers like factories will always be able to predict maintenance in their facilities, and so on. The next key component will be automation, so implementing automated systems for monitoring all of this. So this connects with the Internet of Things, with the sensors and the smart meters and all the components. And finally, one of the more emerging technologies, as well as the AI component, would be the distributed ledger technology, also known as blockchain. And this will facilitate more secure and transparent transactions in the energy market and in the contracts that already exist. So we will see we can expect a shift to smart contracts, and this will be leveraged on distributed ledger technology. So next slide, please. Here now you can see an image of how these technologies are expected to play a role in each of the levels of the energy sector. So from generation to consumption, going through transmission and distribution. You can see the arrows for IoT, data analytics, artificial intelligence, and machine learning, which are coupled together, automation, and DLT, which is distributed ledger technology. For example, here the weight of the arrow translates to the expected contribution of that technology to that sector. For example, DLT, it's not expected to have that great contribution to consumption, but is expected to have a much more important contribution to the distribution sector. The data analytics is very important through all the subsectors from generation to consumption. So next slide, please. Although this is all very well laid out, so all the steps are well laid out from where we are and where we want to go, there are also a lot of challenges that still need to be addressed. And here I've tried to condensate it as much as possible. And these are the 4 main challenges that the digitalization of the energy sector will face in the future. The first one, it's not only for the energy sector, but it's a common challenge in the digitalization as a whole. So not only the energy sector, but all the sectors in society, which is cybersecurity. So with the more, if we're starting to connect all our systems and all our components to the internet, so to say, in a simplified way of speaking, we need to ensure that they are secure, so they are not prone to being interfered by third parties that want to harm the system. So cybersecurity is very important, because if someone got access to the grid, for example, to the distribution grid or to the transmission grid, they can easily turn off systems and turn off supply and turn off generation and so on. So cybersecurity is a very important topic that will also be addressed in the Everyone project. The other one is interoperability. What this means is that we have an open market, so everyone can produce systems to what they believe they have new technologies. So everyone can produce smart plugs, everyone can produce smart appliances, and so on. But we need to assure the society that everything works together. So if I buy something from manufacturer A and I already have some technology from manufacturer B, I need to make sure that they can work together, that I'm not limited to my first interaction with digitalization. So if I started buying from one manufacturer, then I will be tied to that manufacturer, because there's no interoperability. And this is not only on the level of the consumer, on the private citizen, but also at the level of the public stakeholders, the DSOs and the TSOs, and the industries. Another one that is a very important component is data privacy. As you may notice, so far I've talked a lot about data and the amount of data that will be generated through digitalization, but that data can be very sensitive. For example, if a private citizen, if someone can get access to your data consumption, to your energy consumption habits, they can easily infer when you are home, when you're not home, and that can be very dangerous for the private citizen and so on. So data privacy is very important and is also one of the key aspects that needs to be addressed, because if it's not addressed, then people will tend to avoid going to digital technologies. Lastly, it's the skill gaps, which is one of the main points that we are addressing in the Everyone project. So there is a shortage of skilled professionals, both that have proficiency in both sectors, so in the energy sector and in digital technologies, as if they were separated and there's not much knowledge put together in skilled workers. So, and this also translates to low spread literacy in digital technologies in the overall society, so from citizens to government actors and so on. So these are the four main challenges that we aim to tackle in the Everyone project, and they are already being addressed by other projects that I will show you briefly. So next slide, please. So the Everyone has been going on for a year almost, or a year and some months now, but there's already been some development in the past from other projects and other entities. So looking at the challenges that I've mentioned to you before, there's already been work done to solve those challenges. So the Digital Service Act aims to create a safer digital space. So this is linked with data privacy, with digital security, and so on. Regarding artificial intelligence, we have the Artificial Intelligence, or the AI Act, which proposes a legal framework that focuses on the utilizations of AI systems and what are the associated risks with artificial intelligence. And finally, regarding the data protection, one document that we are all familiar with or have already heard of is the General Data Protection Regulation, or the GDPR as it's best known, which aims to protect the fundamental rights and freedoms of citizens and persons, and in particular, what I've mentioned previously, their right to have their personal data safe and protected even when they decide to make it available for other entities to use to improve their consumption and their overall relation with the energy sector. So it's not enough that I have my data protected by myself. So if I'm aware that I'm protecting my data well, I also have to be able to feel safe when I share that data with the institutions that I trust. So this is regarding the documents and some developments that I will present in the next slide, please. So there already been some projects at the level of the European Union that you can check out. Some of them are still ongoing, some of them have already finished. I've tried to focus on what we consider to be the most interesting ones, at least in the perspective of the Everyone project, and these are the EDI project, the Open DEI project, and the ETIPSNet project. So the first one, the EDI project, can be seen as the predecessor to the Everyone project. The end goal of the EDI project ties to the end goal of the Everyone, so they are highly connected. So it's the natural continuation of the EDI project would be the Everyone project. So which aim that it's a cross-cutting project based on knowledge transfer, on the digitalization of energy education. So it's also regarded to the digitalization of the energy sector. And the other project, so the OpenDI aims to be a pillar for the digitizing European industry policies. So it's more related to policies. And the ETIPNet project is for stakeholders and experts in the energy sector to be able to create an expanding network. So next slide, please. So to finalize this first part, we have encountered these 12 brief lessons on Europe's energy transition, and they are all tied to very broad it's a very broad image that talks about a lot of important topics in the energy transition beyond digitalization. So there are others regarding the interconnections between countries, for a social and just transition. They try to address energy poverty, and these are all aspects that are also, if you go through 1 to 12 one by one, you will see that there is one particularly for the digitalization, which is point 7. So it says that digitalization can make this transformation more democratic and efficient, which I have tried to explain before. I hope the message can be clear also when I go through with the presentation, and can reduce the bill for the end consumer. But this is very limitative. So that's not the only goal of digitalization. It's not just to have a lower energy bill at the end of the day. And what you can see here is that digitalization will also tie with all of the other bullets in this image. So it can tackle energy poverty, it can tackle a socially just transition, because if people are informed and if people have literacy in the energy sector and the digital energy sector, it's a more socially just transition, and it can help increasing efficiency, as it's stated in bullet 4. It can produce stronger interconnections of markets, as it's stated in bullet 3, and so on. So as we can see, digitalization, although it's a specific point by itself, it overarches with all the other problems that face the energy transition that we are currently going through in Europe.